Cryptocurrencies are not only a very lucrative source of investment, but they have a lot of intricate math involved and a lot of cryptology involved in that. So today we will be talking about something known as cryptographic hash functions. Now, what exactly is a hash function? Hash function is a mathematical function with the following three properties. It accepts input of any size of string length. So it is accepting string as input of any size, of any length, and it is producing an output which is of a fixed size. It could be 256-bit or whatever the architecture of that particular cryptographic hash function is designed for. So first property is about taking any size of input and converting them into a fixed size output. So that is the first and second property or principle of a hash function. The third property is it is efficiently computable. Now the idea here is that it takes reasonable amount of time to compute the hash or the output of any input to the hash function. So I will rephrase the points here. Takes input as strings of any size or length, produces an output of fixed size. It could be 256-bit or anything depending upon the architecture of the cryptographic hash function. Third is the output of hash function needs to be efficiently computable, which means it takes a reasonable amount of time to compute the output of any input to the hash function. Now this was about the hash function. A cryptographic hash function has three additional properties. These are puzzle friendliness, hiding, and collision resistance. Now we will be talking about collision resistance in this particular video. So what exactly is collision resistance and what is collision? A collision occurs when two inputs to a hash function produce the same output. A hash function is collision resistant when nobody can find two inputs which produce the same output. Formally, let capital H be the hash function. So if x and y are two inputs to the hash function, h of x and h of y are the outputs of the hash function. And if we cannot find x and y such that h of x is equal to h of x, then we say that the hash function is collision resistant. It is important to remember here that we are not saying that there is no collision or there is no existence of collision here. Rather, what we are saying is nobody can find collisions. Now there's a subtle difference over here, because if you think a bit mathematically, as I am providing inputs which are strings of any size or length and outputs are fixed size string, so definitely you will have multiple inputs pointing to the same output as per the pigeonhole principle. Now what exactly is the pigeonhole principle? Let's talk about it. Pigeonhole principle is not very difficult to understand. It is quite intuitive in nature. It states that when you have more items than the number of boxes and you want to put the items in boxes, there will be at least one box which will contain more than one item. Now let's talk about it formally. If n items are being put in m boxes and suppose n is greater than m, then there would definitely be a box which will have more than one item. It could be more boxes too, but there is at least one box which has more items than one. So let us take n is equal to 4 and m is equal to 3. You have 4 objects and 3 boxes. So definitely if you put one object each in the boxes, you will be still left with one object, and that object will need to occupy a box which will have more than one items or one objects. So this is the intuitive idea of pigeonhole principle, and this is at the heart of the collision resistance of cryptographic hash functions. So what we are saying here is there definitely is collisions, there definitely are inputs which will point to the same output, but nobody can find such collisions. Nobody can find those collisions reasonably. So the limitation is not mathematical per se, but more of computational complexity. So essentially, you need to design a cryptographic function which prohibits people from finding collisions. So I will sum it up again. You have hash function which takes input of any size, gives you output of a fixed size. You need to have an efficient way to calculate the hash of any input, and a cryptographic hash function has 3 additional properties: puzzle friendliness, hiding, and collision resistance. In this video we talked about collision resistance. Collision resistance says that nobody can find a collision, or rather nobody can find x and y such that hash of x and hash of y point to the same output. So this was the idea of pigeonhole principle and collision resistance in cryptographic hash functions used in cryptocurrencies. Now I'll be adding more such mathematical videos based on cryptocurrencies. So do not forget to subscribe to the channel and also press the bell icon. And before you go, why don't you leave a comment? Bye bye. Bye bye.